Good morning. Today we are going to discuss about what is stack. Before that, we can learn something about what is data structure and what is abstract data type. So first thing, what is data structure? What is the definition for data structure? So data structure is an arrangement of data in a computer's memory or even on a disk storage. It has a different ways of organizing, storing the data in a computer. So whenever you're going to talk about data structure, it is nothing but arrangement of data in a computer. So why we are going to arrange these data in a computer in the sense in a way that you can store, you can organize the data in a computer using different ways. So what is the concept behind this data structure? So you can manipulate the data. So why you are going to manipulate the data in the sense you can store the data, you can retrieve the data, you can transformation of the user data. So in this basis, the data structures are defined. So the main concept is that the data structures are used for storing, retrieving, and organizing the data in the computer memory. So that is called as a data structures. So what are the different ways how you can store the data? So you can store the data in different ways using arrays, using stack, using queue. In this manner, you can store the data. So next one is abstract data type. So what is abstract data type? So it is defined as a mathematical model with a collections of operations defined on that model. So it supports modular programming. So what are the examples of this abstract data types? In the sense you can say that list, sets, graphs, stacks. So these are the some of the example of abstract data type. So abstract data type is nothing but it is a mathematical operations that defines on that model. So one of the example is stack. So now we are going to discuss about stack. So what is stack, how it is implemented, how it is used, what is the concept behind stack. So these are the things we are going to discuss. So first one, stack. What is the definition for stack? So stack is an ordered collections of homogeneous data elements where the insertion and deletion take place at one end. So whenever you are going to insert an element or whenever you are going to delete an element, that should be done at only one end. That is called as a stack. So you can also say that it stores a set of elements in a particular order. So what is the principle behind this? So you can say it as last in, first out. This is the principle that is used in a stack concept. So you can also call the stack as a last in, first out. So what is the meaning of this? It means that the last element inserted is the first one to be removed. So this is the example. So if you see this example, you can understand that whenever the last element that is inserted should be deleted. So how it is defined, how it is implemented? So whenever you are using stack concept, we are going to use a pointer called top. So why this top is used means it is going to keep track of the topmost element in the stack. So what is the main thing that top plays a role is nothing but it always keep track of the element in the stack. So any element is inserted or deleted should be based upon the value of the top. So we already know that it is based upon the concept last in first out. So whenever the last element is inserted, that is the element to be deleted. So this is the last in first out principle. So next one, we can see some example for this last in first out. So you take four elements, that is A, B, C, D. So I'm going to insert these four elements into the stack, empty stack. So first I'm going to try to insert the element A. After that I will insert B. After that I will insert C into the stack. After that I will insert D into the stack. So when new element E is supposed to be inserted, it is inserted on the topmost element. It is inserted as the topmost element. So whenever I try to delete the element, you have to delete the element. If E is not inserted, you have to delete D. If E is inserted at last, then you have to delete the element E. So if there is only four elements A, B, C, D, so you have to delete the element D first, then you have to delete C, then you have to delete B, and then you have to delete A. So in this way, you have to delete the elements. So this is the example of stack. So this can be represented using this diagram. So you consider this as a stack, and I try to insert A, after that B and C and D. So now at last the top value is D. So whenever I try to insert the element, the top value will be changing. So in first diagram, A is the top value. In second diagram, B is the top value. Since I have inserted B, so next third diagram, you can see that C is the top value because C is inserted. In fourth diagram, you can see D is the topmost value because D is the last element that is inserted in the stack. So now I'm going to delete the elements. So the topmost element D should be deleted. Then C. C is the topmost element at present. So you have to delete the C value. If you delete the C value, then B becomes the topmost element. So in this way, it goes on. So then it will delete B and then it will delete A. Then the stack will become empty. So this diagram explains the last in first out principle. So next one is that the basic operations. So what is the basic operations of stack? So the basic operation is nothing but insertion, deletion and display. So you can say that insertion and deletion can be given as special terms, that is push and pop operations. So how you are going to understand what is push and pop means? So push is nothing but inserting or adding the element into the stack is called push. What is pop means? Deleting or removing the element from the stack is called pop. So this is called push and pop operations. So this diagrams is give a clear idea about what is push and pop. So here you consider the stack of size 4. So whenever you say that the size is 4, it starts from 0 and ends with 3. So 0, 1, 2, 3. So initially the stack is empty, so you can make it as top equal to -1. Then I am going to push an element 10 into the stack. Now the top value becomes 0. Then I try to insert 20 into the stack. Then the top value is 1. If I try to insert 30 into the stack, the top value becomes 2. Then if I try to insert 40 into the stack, the top value becomes 3. If I try to insert or push the element 50 into the stack, already the stack is full. You can't able to insert the element into the stack. Then the condition is called as overflow condition. So you can check the top value whether it is empty or it is full. If the top value is full, you are not able to insert the element into the stack. That condition is called as the overflow condition. So next one, when I try to delete the element from the stack, then you can say it as pop operation. So which element that is inserted at the topmost should be removed first. So 40 is the topmost element. I have removed 40. Then the top value become 2 because I'm going to decrement the top value. Top equal to top minus 1. Then I am going to remove 30. Then the top value become 1. If I try to I try to delete the element 20, then the top value becomes 0. I try to delete the element 10, the top value become minus 1. After that, I can't able to delete any element since the stack is empty already. So whenever I try to delete the element that is already empty, then the condition is called underflow. So this is the thing that when you try to delete the element that is already empty. This is the condition. So you can implement the stack using two concepts. So one is using array implementation and another one is using linked list implementation. Here we are going to discuss about implementation of stack using array. So here comes an algorithm for inserting an element into the stack. So I am going to call the function push. So first thing, I'm going to check the condition. If top equal to size minus 1, then you can say that stack is a overflow. Or otherwise, you can read the items and the top value will be incremented, that is top equal to top plus 1. So I'm going to place the item into the stack top. So now you can stop the algorithm. So this is the condition for inserting an element into the stack. So here comes the explanation. So first thing, I'm going to check the size of the stack for inserting an element into the stack using the array concept. So first you check whether the stack is overflow condition. So how you can check means you check with top equal to size minus 1 condition. If the stack is full, then you can say that overflow. If it is not full, you can insert the element into the stack. Then the top value become top equal to top plus 1. So this is the condition for inserting an element into the stack. So next we can move on to the pop operation. So this is the condition for pop. So this is the algorithm to delete an element from the stack. So here I'm going to call the function pop. So whenever the function is called, you can check the condition if top equal to top minus 1. Then you can write it is a underflow condition. Then you can check that if it is not a underflow condition, you can place the item. You can search the item that is to be deleted, that is placed on the stack top. After deleting the item, you can decrement the top value by top is equal to top minus 1. So we can go for the explanation. So this is the explanation. So what does that mean? I'm going to delete an element from the stack. So first thing, I have to check whether the stack is empty, and I have to check if the stack goes for a underflow condition. So if you check if the top value is 0, then you can say that the stack is empty. So if you try to delete the element from the stack that is empty, means you can say that it is an underflow condition. If not, the element is present, then you can delete the particular element, and then you have to decrement the top value by 1. Then top becomes top equal to top minus 1. So this is the condition for deletion. So next one, we have seen push and pop operation. So there is one more operation, that is one is display. So what does display means? You are going to check whether the elements are present in a stack after push and pop operation. So it is going to print the content of the stack. What are the elements present in the stack? After these many operations, that is, we have inserted few elements, we have deleted few elements. After that, what are the elements that are present in the stack or displayed or printed using the display method? So you can say that I can use the algorithm for display. So here I call the function print. So first thing, I'm going to check for the condition if top equal to minus 1. So you already know that if top equal to minus 1, you can say that the stack is empty. Or else I can go for a for loop, that is, it is going to print the values from if you take I value is equal to 0 to top value. So it starts from 0 and it will check for the, it will increment the I value and it will check for the top condition. Then finally it will print the stack value, the stack of I. So I value varies from 0 to the top. Then finally the values are printed. So what are the elements that is present in the stack or printed using this for loop? Then this algorithm stop. So if you take what are the application of stack means, so it is used in radix sort, it is used in polynomial manipulations and tower of Hanoi problem, and it is used in function call regressions. So these are the some of the application of stack. So well, thank you all for this. Thank you all.